Hello, and welcome to the Daily Space. I am your host, Beth Johnson, and I am here to put science in your brain. The InSight mission on Mars is becoming one of my favorites, not because of its images or its data, although its data is pretty darn cool. No, it is becoming my favorite because of its engineering team's ability to keep overcoming problems with creativity in a way that feels like this mission was written by Disney to be some underdog buddy movie. In this mission's ongoing adventures, the latest chapter includes scientists dumping sand on the lander so the wind would clear the solar panels, and then being able to measure Mars quakes that lasted longer than I care to think about. Let's break this down. Extremely fine dust had been building up on InSight's solar panels, and this was causing the lander to have to make choices about what instruments could be turned on. Without a direct means to clean the panels, the engineering team decided to take a risk and be creative, as they've done before. Using InSight's ever flexible scooper, which frankly every rover should have, they shoveled a bit of coarse sand onto the lander and placed it beside the solar panels in hopes that the Martian wind would push the dust across the panels to remove the dust. And this happened. Go team. With the ability to gather more light and thus more power, the team powered up the seismometer and on August 25th detected two quakes at magnitude 4.1 and 4.2. On September 18th, InSight's 1000th day on Mars, it detected another 4.2 quake that shook for nearly 90 minutes. As someone who lives in California and felt last week's quake while at Disneyland, I have to say, Mars can keep its quakes. The September 18th quake is still being studied, but early results on the August 25th quakes indicate that they centered in two different locations, 575 miles and 5,280 miles from InSight. The exact locations are still being sorted, but neither originated in the Cerberus Fosse, the site of past Mars quakes. It is possible the more distant quake was centered in Valles Marineris, the largest canyon system in the solar system. Here is to hoping the scientists move quickly, and we can tell you more about Mars' active lifestyle in the near future. The universe is shake, rattle, and rolling. Worlds large and small aren't the only places where shock waves can boop things into reacting. Things don't go gentle into that good night. Instead, the universe is filled with powerful jets, shock waves from all manners of explosions, and on the large scale of solar systems, giant planets can leverage their gravity to fling rocks at other worlds. It has long been known that the first step in forming new stars is the collapse of giant molecular clouds into fragmenting pockets of material. Exactly what causes the collapse? Well, there have been theories, but thanks to a team led by Shmuel Bialy, data now points directly at supernovae. In analysis of Gaia data, this team identified an empty sphere more than 450 light years across that is located between the Perseus and Taurus molecular clouds and star-forming regions. They believe that either a single supernova or a series of supernovae over time blasted that sphere empty of material and also booped the nearby Perseus and Taurus clouds, triggering star formation in both systems. These results are possible because of Gaia's amazing ability to discern accurate positions of distant objects. Co author Catherine Zucker explains: "We've been able to see these clouds for decades, but we never knew their true shape, depth, or thickness. We also were unsure how far away the clouds were. Now we know where they lie with only 1% uncertainty, allowing us to discern this void between them." Bialy further explains, "Hundreds of stars are forming or exist already at the surface of this giant bubble. The galaxy is a dynamic place, and from the shocking death of at least one star, myriad more have been born." Science develops in lots of ways. There are purposeful discoveries like the Mars quakes, where researchers have a target, have some sort of expectation, and they get data from that target to see if their expectations are true or false or sideways. Other times, discoveries occur completely by accident. This is the case with the discovery of two radio bright galaxies that photobombed ALMA observations of a completely different pair of systems. Researchers led by Yoshinobu Furumoto were surveying distant galaxies as they appeared when the universe was just a few percent of its current age. In two of the 40 galaxies in the survey, stray light was spotted that was eventually matched to a pair of previously undiscovered galaxies that can't be seen in shorter wavelengths of light. Dust is one of those things that is almost everywhere. And just like a lot of dust in the air will block blue shades of light and make everything appear red, dust in the galaxy can block all the short wavelengths of light and make things only appear to radio telescopes. In a new paper appearing in Nature, the team discusses the possibility that there is a significantly larger population of these massive distant galaxies than previously thought. Those galaxies are just hidden by dust. After the break, we'll be back to look for other things hidden in our solar system, and in one case, even hidden here on Earth. For the last week or so, the Europlanet Science Congress has been going on online. Everything is still mostly virtual, which is kind of great for science because it means a lot of us who couldn't afford the travel and meeting fees are now being exposed to amazing science. EPSC is a big planetary science conference, which means it's my bread and butter. And there are so many interesting stories coming out of the conference that I had a difficult time choosing a few for today. There will be more tomorrow, I'm sure. So let's start with the one very close to home. And by home, I mean right here on Earth. Back on February 28th, 2020, a fireball was seen in parts of Eastern Europe, such as Slovenia, Croatia, Austria, and Hungary, in the morning sky. The path actually went right over Slovenia, where people reported explosions, a long flash, and even a visible dust trail. Then people started reporting their experiences online and uploading videos from dash cams, security cameras, and a cyclist's helmet cam. Using all of the data collected, scientists were able to not only trace the path of the fireball through the sky, but also recover fragments, including three fragments that come to about 720 grams of space rock. The largest fragment seen in the videos is estimated to be about 10 kilograms, but has yet to be found. Dr. Dennis Vida from the University of Western Ontario presented the findings, explaining by combining observations from several cameras around 100 kilometers apart, a fireball's position can be pinpointed to within 50 meters, and it's usually fairly easy to compute its atmospheric trajectory and pre atmospheric orbit this way. The fireball's path is in a volume of the world's sky among the most densely observed by special night operating cameras. Its path would have been caught by at least 20 if it had happened just a few hours earlier. But because this fireball occurred during the day and was recorded by dash cameras moving up to 70 kilometers per hour, we required a different approach. On top of all the video footage they did have, local people became community scientists by taking pictures of buildings, telephone poles, mountains, and other landmarks in the videos, which were then analyzed to determine the exact track and location of the fragments. Yay, science! Now, getting samples of space rocks as they land here on Earth is one way of doing planetary science. Another way is to send robots and maybe even people to other planets to gather samples. But before we can do that, we have to design and test rovers. And what better places to do that testing than analog sites of other planets? In July 2021, 11 students from all over Europe were brought together on a field trip to Mount Etna in Sicily. And there, they tested a miniature version of the European Space Agency's next Mars rover, Rosalind Franklin, which is scheduled to launch aboard ExoMars in 2022. Team member Hannah Riley from Technological University Dublin explains the location. Sicily was chosen due to the fact that Mount Etna is a very similar environment to the Moon and Mars, being fairly desolate, harsh environments. The constant volcanic activity at Mount Etna means that the terrain and surrounding areas are constantly changing and covered in fresh volcanic soil, similar to soil found on other planets. Volcanic areas are usually chosen for campaigns like this. The team developed their own camera, which could generate 360-degree panoramic images. They had several different types of spectrometers on board so that they could analyze the terrain. They collected samples on site and were able to analyze them with the rover's instruments. And all of this work gave field and analysis experience to students as well as a chance to write papers based on the results and present them at the conference. That sounds like an amazing opportunity all around, and frankly, I'm a bit envious. Finally, our last EPSC story today goes farther out into our solar system to talk about ammonia mushballs at Uranus and Neptune. We've talked about these mushballs before with regards to Jupiter, but now scientists have found that they could solve a mystery on the two ice giants. Remote observations of Uranus and Neptune at long wavelengths in the infrared and radio have found that the two planets lack ammonia, especially compared to Jupiter and Saturn. They have a ton of methane as expected, but not so much ammonia. And data from NASA's Juno spacecraft has shown that ammonia is abundant at Jupiter, but also much deeper into the cloudy atmosphere than expected, which is where the idea of the ammonia mushballs came from. As the press release explains, the Juno observations at Jupiter have shown that ammonia water hailstones can form rapidly during storms because of ammonia's ability to liquefy water ice crystals even at very low temperatures of around minus 90 degrees Celsius. Models indicate that these mushballs in Jupiter may grow to weights of up to a kilogram or more, slightly higher than the largest hailstones on Earth. As they plunge downward, they transport ammonia very efficiently to the deep atmosphere, where it ends up locked away beneath the cloud base. As for the ammonia at Uranus and Neptune, presenter Tristan Guillot said, thermodynamic chemistry implies that this process is even more efficient in Uranus and Neptune, and the mushball seed region is extended and occurs at greater depths. Thus, ammonia is probably simply hidden in the deep atmospheres of these planets beyond the reach of present day instruments. Those darn giant planets hiding all their ammonia away from our instruments. Now we just need to send orbiters to Uranus and Neptune to confirm. I'm all for that idea. After the break, we'll look at some wild results found in data collected by the Hubble telescope and ALMA observatory, which found far distant galaxies that had run out of star forming fuel. Stay tuned. One of the most amazing things about current astronomy is how researchers are finding ways to tease out answers to questions all of us expected to see the JWST solving. As that telescope is now about more than 10 years late to launch, at a certain level, people just got tired of waiting. Also, we still have Hubble, and now we have the ground based millimeter and submillimeter telescope ALMA. Working together, these systems can identify high mass galaxy clusters that can gravitationally magnify more distant galaxies. While this gravitational lensing acts more like a distorting funhouse mirror than a perfectly formed lens, the systems, however distorted, are still magnified, and this allows us to see things otherwise too far away in this pre JWST era. And sometimes it even lets us see things we didn't expect to even see with JWST. In a new study appearing in Nature and led by Catherine Whitaker, researchers looked at massive distant galaxies whose light has been gravitationally lensed. Six of these systems appear to have already exhausted all of their star forming material when the universe was just 3 billion years old. This was not expected, and now the question becomes how? One of the startling revelations of the past decade has been that galaxies form in different ways. Early on in the universe, massive galaxies could form through the collapse of massive clouds of material. Small and medium sized galaxies could also form this way, and since the beginning, there have been galaxies in all sizes. Over the past 10 billion years or so, smaller galaxies have merged together to form bigger and bigger systems, and massive systems have periodically eaten smaller systems and gained a bit of girth in the process. In trying to understand how the massive systems used all of their star forming material so quickly, researchers are considering different options. According to Whitaker, we need to ask, did a supermassive black hole in the galaxy center turn on and heat up all the gas? If so, the gas could still be there, but now it's hot. Or it could have been expelled and now it's being prevented from accreting back onto the galaxy. Or did the galaxy just use it all up and the supply is cut off? These are some of the open questions that we'll continue to explore with new observations down the road. In theory, when and if JWST is successfully put into action, it will be able to directly observe these kinds of systems without relying on the image distorting effects of gravitational lensing. In theory, the wait is almost over, and the telescope should finally be launching later this year. Of course, they said that back in 2018, and then it didn't launch. So here is to hoping, but now counting our telescopes before they launch. After the break, we'll be back to look at what's up in our skies. Coming up soon is the last phase of the lunar cycle, the new moon. During a new moon, the side of the moon that faces the Earth is directly aligned with the Earth, so it is not illuminated by the sun at all. It is also up during the day and close to the sun, so it is harder to see safely. This particular event is useful for several reasons. For visual astronomers, faint deep sky objects will not be washed out by the moon's glare. This makes the days around the new moon the best time to see these objects. Another thing that is easier to see on a new moon is a meteor shower. One, the Draconids, is coming up early next month and it will fall around this new moon. More details on that closer to the event. Another reason the new moon is a useful event is it marks the highest ocean tides of the cycle. If you remember the time the container ship Ever Given was stuck in the Suez Canal back in March 2021, truly, truly a highlight of Pandemic Blur's Day, it was refloated after 6 days due to the efforts of Egyptian workers and also the high tides of the new moon. The new moon also carries cultural significance. The Islamic calendar is based on the lunar cycle, so the new moon marks the beginning of a new month. The holy month of Ramadan begins and ends with visual observations of the new moon, or after 30 days if the moon cannot be seen. In Western culture, the new moon is the first phase. Back to what you can see in the sky during a new moon. With the equinox having happened a few days ago, the nights are getting longer and colder in the northern hemisphere. There are lots of cool things to see now and in the coming months in these improved conditions. Perhaps the most interesting object to see is the Great Orion Nebula. This object is bright enough that you can see it with the unaided eye as something that isn't a star in between two actual stars in the constellation Orion. With binoculars such as 10 by 50s or 15 by 70s, you can see the fine details in the arms of the nebula and the smaller Demarans Nebula below. In a small telescope, you can see much more detail, including the trapezium cluster, the 4 stars at the center of the Orion Nebula. In an even bigger telescope, at least 127 millimeters, you can see at least 6 stars in this cluster. They are some of the youngest stars in this star-forming nebula, the closest one to Earth. Finally, Orion stars can be used to find other constellations where there are other cool things to look at in a telescope, especially during this new moon. For example, following the outer stars in the belt leads you to Sirius and the core of the Milky Way, rich in deep sky objects. The other direction leads to Aldebaran, which is in the constellation Taurus. Near Aldebaran is Messier 45, the Pleiades star cluster. This is one of the greatest open clusters to see in any optic form, from low power binoculars to a telescope, even the unaided eye. It is full of dozens, actually hundreds, of bright young stars and even some nebulosity or gas illuminated by these stars' lights. Remember, go outside and look up. This has been the Daily Space. You can find more information on all of our stories, including images and sky charts, at dailyspace.org. As always, we're here thanks to the donations of generous people like you. If you'd like to support us, please consider joining our Patreon at patreon.com/CosmoQuestX.